All right, dear alert physics students, today, right now, trigonometry. Now, all of you have at least heard the word. Most, if not all of you, have at least seen the subject briefly in high school. And some of you might have seen it some in college, depending on what, you post-backs at least, your major, I don't know. Or maybe some of you who are undergrads might have seen it before. I don't know. Trigonometry, trigonometry, triangle, has to do with the study of triangles. And we're going to restrict ourselves pretty much to the study of right triangles. If it's not a right triangle, it's a wrong triangle. Don't forget. Okay. So it's about triangles. Okay. And in particular, three functions that show up a lot when we deal with triangles. Here's a nice 3, 4, 5 triangle, not drawn to scale, but there it is anyway. Nice 3, 4, 5 triangle. Okay. The functions that are important to us, let's see, where's my green? I'm going to use my green here, are these. And they're functions of that angle there, that little circle with a line through it, that's theta, Greek letter theta, lowercase. They are functions of that angle. So there is something we call sine of theta, something we call cosine of theta, and something called tangent of theta. We don't write out the whole thing. It's S-I-N-E, C-O-S-I-N-E, and T-A-N-G-E-N-T, tangent. They're sine, cosine, and tangent. And they're defined, remember 3 lines means defined, in terms of the sides of the triangle relative to theta. Those sides have names. You will remember these. The long side is known as the hypotenuse, of course. Okay, that's the long side. If the angle is here, the side that does not connect with that angle at all, over here the y equals 3, this side is known as the opposite side. And the side that is not the hypotenuse that the angle does connect with is known as the adjacent. These are probably all at least vaguely familiar to you all. So those are the names for the 3 sides, and they are defined relative to theta. Well, actually, hypotenuse doesn't matter what angle you're talking about, but the opposite side here is defined. It's opposite of what? Opposite of theta. Adjacent is also defined in reference to theta. Hypotenuse is not defined in reference to the angle. Okay, but the opposite is, and the adjacent is. The opposite is the side opposite the angle. The adjacent is the side adjacent to the angle. And these 3 functions that are written here are defined in terms of these 3 labels. Okay. Sine is defined as the opposite over the hypotenuse. The cosine is defined as the adjacent over the hypotenuse, and the tangent is defined as the opposite over the adjacent. And these are the fundamental definitions, pardon me, that are always true. Okay? Always true. Okay? Sine is always the opposite over the hypotenuse. The cosine is always the adjacent over the hypotenuse. And the tangent is always the opposite over the adjacent. Now, in this case, okay, in this case, we have labeled the opposite y. We have labeled the adjacent x. And we have labeled the hypotenuse r. So, taking these general definitions that are always true, and applying them to this triangle, we get this. Sine of theta is opposite of our hypotenuse, which is y over r. Cosine of theta is the adjacent over the hypotenuse, so that's x over r. Okay. Tangent of theta is equal to the opposite over the adjacent, so that's y over x. Okay. Now notice we can write these into the first two. I'm not going to worry about rewriting the third one. But we're going to, in many, many, many situations, coming up imminently, write these slightly differently. We're going to write that y is equal to r sine theta. All I've done is multiply both sides by r. Right? If I multiply the left-hand side by r, I get r sine theta. If I multiply the right-hand side by r, I just get y, because the r's cancel. Similarly, for this formula, x is r cosine of theta. Okay? All right. Let's see what else to say. Yes, and we can actually now align here. And we can actually find numbers for these. So, sine of theta, right, is y over r. And I just want to back up to this again. These are going to be useful very soon. I just wanted to show you how we got from that to that. Okay. And you're going to see why that's useful, again, when we get back into the vector chapter. Okay. Sine of theta is going to be y over r. Y is 3, r is 5, so it's going to be 3/5. So that is 0.6. For this triangle, sine of theta is 0.6. Cosine of theta is the adjacent over the hypotenuse, which is 4 over 5, which is 0.8. And the tangent of theta is the opposite over the adjacent, which is 3 over 4, which equals 0.75. The point being here, okay, that for a given triangle, sine theta, cosine theta, tangent theta, all have specific unique values for that triangle. Okay. All right, you just plug them in to find the sine, cosine, and tangent. All right. Okay, I do want to add one more thing here at the bottom of the screen, and that is a couple more relationships that connect x, y, r, and theta. We've got a couple here, we've got a few here, but there are a couple others. And one of them, you're going to be familiar with the name at least from somewhere back in your past, the Pythagorean Theorem. Which says that the hypotenuse squared equals the opposite squared plus the adjacent squared. And that's always true. That's always true for all triangles everywhere. In this case, right, we have these values given here. This means that r squared is x squared plus y squared. Okay? So that is the Pythagorean theorem expressed for this particular case. Okay? And also, one more relationship. Theta is always the inverse tangent. If you look on your calculator, there's going to be a second function button somewhere. If you press that second function button, then tangent, it'll give you what's known as the inverse tangent. And theta is the inverse tangent of the opposite over the adjacent. And again, this is always true. In this case, theta is the inverse tangent of y over x. Okay. So we've got our always true definitions here. And then those definitions applied to the case of this triangle. Then we have these two other connections between these values, Pythagorean Theorem and this expression here. Those are always true in pink, and in this case true in green. Okay. And if you do this for the angle that we have here, right? I'll go ahead and do this right down here. Go ahead and show you how to calculate this. In this case, theta, whatever you call that thing, theta is equal to the inverse tangent of y over x, which is 3 over 4. So if you divide 3 by 4 and get 0.75 and take the inverse tangent of that, it should come out to be about 37 degrees. So this angle here is about 37 degrees. Okay. So all I've done here is express to you a few formulas that relate x, y, r, and theta. Okay? X, y, r, and theta. That's all these values do. That's what all the Pythagorean theorem does. That's all this angle formula does. That's all these definitions of sine, cosine, and tangent do. They relate these four quantities: theta, r, x, and y. All right. And next video, we're going to see how this applies, how this helps us with vectors. And I should say also that some of this information I've given in this particular video is available in the appendix, early on in the appendix in your textbook. I think it might be the first or second topic that shows up in the appendix at the back of your textbook. So some of this is not actually in section 3.2, but this information does relate to section 3.2. But if you want to review this information in your textbook, look in the appendix. Okay? All right, so coming up next, we're going to apply this to vectors.